All right, so there's a couple special cases of factoring. If you remember back on chapter 6, we had two special cases where you multiplied, and I go over those special cases. Let me give you a little rundown here. You know, when we have x plus 3 times x plus 3, we talked about that being, let's go back here, x plus 3, the quantity squared. And this one over here, x minus 3 times x minus 3, we talked about that being x minus 3, the quantity squared. And we actually told you that all you have to do when you see this is take this x, square it, okay? Take this 3, square it, it goes in the last term. And the middle term is this x times this positive 3, which is 3x, doubled, which is 6x. So we let you get away with not writing all this jazz down here. Okay, so over here, same way. When you have x minus 3, the quantity squared, you can do it the long way always, but you can take this and x and square it. Take this negative 3 and take it times itself. It's the last term. Negative 3 times negative 3 is positive 9. And then this middle term is x times negative 3, that's negative 3x, doubled is a negative 6x. Now you're doing the reverse. And the reverse is something a little bit like this right here. 9x squared plus 42x plus 49. And we're saying, does this thing factor? Well, it's actually a special case, and let me show you why. You go and you look here and you go, is this a perfect square? Can some number times itself get you 9x squared? Yes, it can. Okay. In fact, it can be 3x. 3x times itself is 9x squared. You're actually looking here. Is 49 a perfect square? Some number times itself. Can it get 49? Yes, it's 7. Okay. Then you say, okay, does this number 3x times this number 7, which is 21x, doubled, give you this middle term? Yes, it does. Yes, it does. Okay, so this is, we can factor into this format back here. So what we do is say, hey, this is a perfect square trinomial. It's some binomial times itself. Okay, and what we're going to do is we're going to put this, the root of this, in the first term of the binomial. We're going to put the root of 49 in the second term of the binomial, and the sign that goes right here is the sign that is right here, plus. And then this is the quantity squared, or 3x plus 7 times 3x plus 7. Okay, that was one of them. The other special case was this one, where you had x plus 3 times x minus 3, where you had the same terms in the binomial with different signs. And what happens is this middle term cancels, and you actually get x squared, and then you always have a minus here, because remember, it's a positive times a negative gives you a negative. So you have a perfect square, and a perfect square here, and a subtraction. We call this the difference of two squares. Okay? And how you do this is you go and you say, hey, is this a perfect square? Yes, it is. It's A. Is this a perfect square? Its root is A. Is this a perfect square? Yes, it is. Its root is 4. Okay? Does it give you a difference of two perfect squares? Yes, difference of two perfect squares. So what we have is, and you can look up here to see, we have something plus something and something minus something. And what happens is we put the root of this first one in the first term, and the root of this second one in the second term. And you can use FOIL method to see if that's right, but this is your answer. I probably should have boxed this one in too. Alright, so if this one can factor that way, it has to be a perfect square trinomial. So we look at this one right here. Is it a perfect square? Does it have something times itself give you 4x squared? Yes, it does. It's 2x. Is this one a perfect square? Something times itself is a positive 9. Yes. Well, I mean, it doesn't have to be a positive 9. It could be a negative something times itself. Yes, 3. Okay, now, Multiply 2x times 3, that gives you 6x. Double it, does it give you 12x? Yes, it does. So what happens is this is a perfect square trinomial. It can be factored the shortcut method by saying, hey, this first term is this root, 2x. This last term is this root, 3. And what was this sign right here? This sign was the sign of this one. It's minus. So this should be 2x minus 3, the quantity, squared. Okay, right here. See right here? Difference of two squares. Right? Difference meaning subtraction of two perfect squares. What's the root of 9x squared? 3x. What's the root of 16? Oops. 4. Okay? So what happens is there's no middle term, so something has to cancel. That means we have a positive and a negative in here. Here we have 3x. Same way over here, 3x. Here we have a 4. Here we have a 4. There's your answer right here. And we will talk about it more in class.
Made with Doodlecast Pro.